Welcome, everyone. In his letter to the Romans, chapter 1, verse 20, Paul wrote that the invisible qualities of God have been seen since the creation of the world. And it's kind of a play on word, I think, that he does there, because he said the invisible qualities have been seen. But I think in some way it's something that, we spoke to us when we look at the creation. The creation show clearly some of the qualities of God. And I think in this passage, when he wrote that in chapter 1 of Romans, he's addressing people to say that they have no excuse. You have no excuse to not believe in God, to not be faithful to Him, to not obey Him. You have no excuses. Whether you are Jew and have been following the law, or whether you were Gentiles, and have not followed the law, you have no excuses. That's what he's talking about in that chapter. For Paul, God's qualities are evident in the creation. The Gentiles who did not have the scriptures have no excuses, as I mentioned. And I do believe, like Paul, that the intricate beauty and the complex design of the creation demonstrate that a designer planned it all. Other passages speak the same way. For example, in Psalm 19, verse 1, you can read, "The heavens declare the glory of God. The skies proclaim the work of His hands." Job also, in chapter 12, verse 7 and 8. Job answered one of his friends, he said, "But now, ask the animals and they will teach you." By the way, that's an ET version here that I read. "Or the birds of the sky, and they will tell you. Or speak to the earth, and it will teach you. Or let the fish of the sea declare to you. Which all these does not know that the hand of the Lord has done this." That's chapter 7 to 9, sorry. So, and it was also many other non-biblical authors have inferred that there must be some kind of a creator, a God behind everything. For example, you can think of Plato. He wrote in his writing called Timaeus. He wrote that there must be a being of supreme wisdom and intelligence who is the creator of the cosmos. Plato's argument is now called what we call the cosmogonical argument of the creator. Some scientists have also shown more recently that if you would change a little bit the laws of physics, you would change a little bit a constant, like either the constant of the speed of light or other constant, light would be unlikely. All those have to be very well adjusted and put in place so we can have life and an intelligent being existing in the world. One thing that also I find personally very incredible is not parables, but something related to parables. I guess you can see the stripes on the parable, the ellipses, the diagonals. And you have some like that, as I showed you with my hand here, but some the other direction. So what you have here is like, some interlocking helices. The way a parable grows is very fascinating. It takes about 3 years to get a parable from the plant. Almost a year for the flower to develop and come to maturity, and then produce some berries, and the berries coalesce into a large compact fruit. The fruit is arranged into interlocking helices that always follow that same pattern. And you have 8 helices in one direction, 13 in the other direction. Always the same number, 8 and 13. And keep in mind those numbers, 8 and 13. We'll come back to those numbers later on. So what you have in the paper is this, a sunflower. And you can see on the sunflowers, you have helices as well. Similar to a bit like what you have on the purple. So you have helices going in that direction and helices in the other direction. You can clearly see. A purple has 34 helices in one direction and 55 helices in the other direction.
You mean a sunflower?
Sunflower. Thank you for correcting me. And it's always the same numbers that comes always. I'm not sure it covers all type of sunflowers, but I mean that type has clearly those helices. And they have always 34 and 55 in all cases. And why do we have those numbers? Why do we have like 8, 13 for the purple and 34 and 55 for the sunflower? It's called the Fibonacci sequence.
Oh yeah.
Okay.
So,
There you go.
so
He's getting happy over here.
for the Fibonacci sequence, you start with the first two numbers, 1 and 2. You add them up. It gives you 3. You take the last two, you add them up. 5. And you go on. Always the last two that you add up. There we find the beginning of a sunflower. Pineapple, sorry. 5 and 8, 13. So that's the numbers we find for pineapple. After that, 21. 21 and 13, 34. 34 and 21, 55. Which are the two numbers that I mentioned for the sunflower. So it's really intriguing. What did I do? I just take the first two numbers and apply additions. Very simple. I add numbers, just as simple. I got those numbers, and those numbers are very present, particularly in vegetables. As I've shown for the pineapples and the sunflowers. It's a bit hard to explain why you have Fibonacci numbers so present in nature. For the sake of simplicity, I would say here that those numbers are not far from something that is called the golden spiral growth. It's the way the way you build that spiral. I'll give up on that drawing. The thing is that you can search. If you search on the internet, you'll see a much better drawing of what we call this golden spiral. It's the way that spiral grows. And the growth that we see in those plants are very related to that spiral growth. And actually, the Fibonacci numbers are not exactly exact representation of that spiral growth, but it's very close. So that's why we can clearly see those numbers come back. So the point that I'm trying to make here is that things are not that seems sometimes random are not arranged randomly. Very complex systems that seems to have like almost random rules of growth or things like that seems to show a sequence and things that are very cohesive and simple. The universe, though that may seem very complex, reveals itself in a beautiful and coherent structure. Another example is a bit further away from what we know. It's related to what I did my thesis on. I did my thesis on a field that is called strongly correlated systems. We applied some theory, something that is called the quantum statistical mechanics, to study a large number of particles that are put together. And we see that in some very special circumstance, those particles can show a behavior that goes beyond what we could expect. That's what we call strong correlations. So one of the system I studied during my thesis is called superconductors. Superconductors, we can think it's a conductor that is better than other conductors. It's not exactly simply like that. If you would take a superconductor at room temperature, it would be a pretty bad conductor. You have to cool it down at cool temperature, and then it becomes not just a good conductor. It kind of looks like a perfect conductor. Why? Well, nothing's perfect in this world. That's what usually people think. We think that nothing is perfect. But these things are perfect conductors. We are unable to measure even with the most precise instrument. I don't remember the length. I know it's around a few meters that they tried to pass to have an electrical signal going to one of those superconductors, and they were not even able to measure any resistance over all that distance. And the thing is that now we understand since the 1950s how superconductors work. And what makes it being so perfect in conduction is that electrons, the valence electrons is the electrons that participate in the conduction in a conductor. Those electrons stop being independent of each other. They behave as if they were on a single particle because they are perfectly coherent and correlated in their movement. So that's how we can have that perfect conduction. And I find it really interesting to see that we talk about quantum physics, and usually when you talk about quantum physics, you think it's related to very small things. But that superconductor, you can touch it. It's not small. We're talking about something, probably you will warm it too much if you touch it, but if you don't touch it for a long period, it will stay a superconductor. It's something visible that is tangible and can have that property of being perfect in some way. And why do I bring that subject here is because I think that in some way God reveals aspect of himself in his creation. And I think that it's really interesting to hear about those things because we're talking about something that has a perfect behavior. We're talking about losing particles that lose their identity, that they become completely united, as if it was one. And that makes me think about when you read the Bible and Jesus saying that he's one with God. We in Ephesians, Paul call us to be one. I don't mean that we can be correlated the same way, but I think it's an image of God shows in very simple things that's how we love things to be. Perfect is something that in some way seems an ideal for us, but can be seen in the world. Okay, let's talk about my second part of my talk this evening is about the creation. So I would like to start with a quick survey. How many of you have heard of the Big Bang Theory?
The show or the theory? Sorry.
The theory, not the show.
I had to say it.
How many of you? So feel free, don't feel judged here. So how many of you believes that it could partly explain the creation of the universe? Somewhat. Okay. How many of you have encountered non-believers who say that they believe in the Big Bang Theory, so they don't believe in God? Yeah, many of you. I did encounter that too. So I want to show that it's not. You can believe in the Big Bang Theory and still believe in God, and it's not exclusive to each other. That's what one of the main points I'll cover here in that part. So let's consider the biblical record of the creation of the world.
Yeah.
In Genesis 1:1, it says, "In the beginning, God created the heavens and the earth." I'm not a specialist. I don't know Hebrew. I don't know all Hebrew that we find in the Bible. But there's an interesting guy that did the talk. He called his talk Science and Faith. So, but he covers mainly the scriptures part and explain things in the scriptures. His name is Tim McKee. We can probably find in most podcasts. You can find his talk about that. And he talked about the origin of the words. What words are used in that passage? In the beginning, that's one word. And the word that is used in the Bible is rishit. So that's come from Tim McKee presentation. What we hear usually when we think about that, in the beginning, we think about something punctual, in the past. That's where it started, the beginning. But he explained that there's a word in Hebrew for meaning like that precise time in the past of the beginning. And in Hebrew, and the word is not rishit, is the word tehillah. That's the meaning of a very precise and point in time that marked the beginning of something. Rishit is a term that is refer to an undetermined past. So it doesn't refer necessarily to a very specific beginning. It could be translated as the source, but it could also be simply meaning a former state of something. So it's not very precise. And there are also, if you read other texts, Egyptian texts, Canaanite texts about the origin of the world, there are quite a bit of resemblance with the one we find in Genesis 1:1. So in some way, it seems that, but quite many resemblances, but also some differences. So in some way, it seems that the Hebrew, with their description of the origin, they are kind of, that comes from God, but they in some way answer these people to correct the way they believe the creation was made. Hebrews had no concept that we could create things from nothing. They go. You're in Hebrew at the time, like 3,000 years ago. You walk around. You come to some places, and then it's a wilderness. And what they call a wilderness is desert. It's wide and it's long, and you will not go very far in that place because you know that you will likely die because you have nothing to drink, and so that's one extent. And the other direction you go, it's sea. And then there either you can go fish a little bit, but not too far because you're not sure that they will be able to come back. So for them, the concept is that, okay, we have this land that is fertile, where we can live, and it's surrounded by desert and water. So for them, the creation is that how God made that space livable for man and for humankind out of where the desert and the sea stops. And so the interest in explaining the origin is to explain that the God they love gave them that place where they can live and they can flourish. So that's why I think that many believe that the biblical account is not to be considered as a precise and explanatory description of the creation, but of a creation of the place where the Hebrews lived and where they discovered the Creator. To me, the biblical account of the creation cannot be considered in opposition to the Big Bang theory or to any scientific theory of the creation. It is an account that makes sense to the first listeners of the Bible and that was speaking to them. Where's the Big Bang theory and how they would come up with that? So for that, we'll go back at the beginning of the 20th century. In 1905, there was something important that happened. Albert Einstein published the first paper on the relativity of space and time. And that paper has really been a revolution because it provided many answers that people were trying to understand. After that, he worked for about 11 years on what we call the general relativity. What was the difference with his first paper was that he was trying to include gravitation in his theory. And he worked with great other mathematicians and other physicists to develop that theory. He came with two main problems. And one was that there could be some body with enough density such that even the light would be trapped by those bodies. So that's what we call nowadays a black hole. Yeah. And I don't know if you have heard in the news, I think it was last week or 2 weeks ago, there was a first picture of a black hole. Mm-hmm. But it was very uncomfortable with that idea. At the time, we had no idea that such a thing could exist. And it was very uncomfortable that it's something that his theory could show. Before that, we thought, light, we were not sure if the light of speed was infinite or finite. It took a while, but then it shows, most experiments showed that it was a finite value. And his true Einstein's theory of relativity, we understood how it could be finite and still seems to be the same speed for everyone. Whether you're walking or you're staying in a place, you would always measure the same speed of light. And then, his new theory, the general relativity, was supposing that such body exists that can trap light. But I'm going a bit far from my subject here. The second issue he had was that in his model, the stars would move. They would not stay in place. And people have been looking at the stars for years and years and years, and it seems that they don't move. And he was very uncomfortable with that. But this, he was able to correct it. I would say correct it, to modify it, I should say. He added something in his equations that was compensating the movement that his equations were giving and removing the movement of the stars. So his model, without losing the basic of it, he added that term that keep the stars fixed. And that, he was satisfied with that. So that's the paper he published. And some years later, he would say that was his biggest mistake. Nevertheless, his theory was successful. It was able to explain things we were unable to explain. Astronomers have been looking at the planets, for example, and they were able to explain their movement except for Mercury. Using Newton's theory of gravitation, we could not explain the movement of Mercury. There was something wrong. And with Einstein's theory of relativity, we could explain exactly the movement that Mercury is doing around the sun. And the main things, often people think that Newton's theory of gravity and Einstein's theory of relativity, of gravity to relativity, is pretty much the same. It's pretty much the same at all levels. It's not the same when we talk about big and huge mass, and we're close enough. Mercury is pretty close to the sun, and the sun is very massive, so that's why for the trajectory of Mercury, we were not able to explain it. Just a few years after, about 10 years after, 12 years actually, after the publication of Einstein's theory, in 1929, there was someone who studied, his name is Edwin Hubble, we named a telescope after him, the Hubble telescope, discovered that it seems that all the stars are moving away from each other, away from us. Because that's very simple. At the time, we started to understand what is nuclear physics. And we knew that nuclear physics, when you merge two hydrogen together to become an atom of helium, they produce some gamma rays with and some light with a very specific light. And when we study those spectrum from those stars, there was some kind of what we call the Doppler effect, some kind of redshift. So that when something, if you look at the source of light and it moves away from you, that source of light will look more red. And if it comes toward you, it will look less red. That's what we call the Doppler effect. That's what police officers use to get your speed, is by sending some kind of microwaves that bounce back, and they measure the difference of wave. So it's exactly the same effect that allows to measure at distance speed of something. So we can see that stars are going away from us. That was first going against that thing that was an issue for Einstein. You know, the stars would not be fixed. They are going away from us. And the other thing, it was like, it was something we did not expect and we could not understand. Based on that work, 2 years later, in 1931, a physicist called Georges Lemaitre, a Belgian physicist, came up with a theory. He said there's an evidence that God created the world. The universe is an expansion because originally everything was together. And there was kind of an explosion to bring things apart. And that's use the general relativity of Einstein and that expansion observation to build up that theory of the Big Bang. What is interesting to note is that, you know, Georges Lemaitre was a Catholic priest.
Oh, he was.
He was a mathematician, an astronomer, and a professor of physics at the Catholic University of Louvain. He viewed his theory as a proof of the creation of the universe. He believed that the explosion was God intended. His theory was met with much skepticism at the time. Even though Hubble's observation seemed to show that the stars are getting away from us, people were still believing that the stars were fixed, and they didn't think that Hubble was right either. Even Einstein did not believe Lemaitre. He said, "Your calculations are correct." He told him, that's what it was recorded. Your calculations are correct, but your physics is atrocious. In an interview with the BBC, a respected astronomer by the name of Fred Hoyle said, a way of mocking Lemaitre's theory, the universe was not created in a Big Bang, and the moniker stuck. And Lemaitre's theory was now, from that time on, named the Big Bang theory. He had named it differently. It took about 20 years for the theory to be globally accepted among physicists and astronomers. The Big Bang theory has evolved over time. People have added other things like possible inflation at the beginning. There's quite a bit of things that, you know, we're not even sure that inflation made sense. They happened. There are things that are not completely explained by the Big Bang theory. But on the other hand, I would say that there are clearly some observations that corroborate the theory. First, the observation that the stars seems to go away from us. And the second point is that we discovered in the 1950s that there seems to be a cosmic, what they call the fossil cosmic background, which is kind of a microwave radiation coming from everywhere in the universe. It seems to be spread everywhere. So why do we have that radiation? Where it comes from? So it seems to be a remnant of that original explosion, if I can say. It is ironic that, you know, in today's secular world, people often cite the Big Bang theory as a reason to not believe in God. when in fact Lemaitre viewed it as an explanation of God's divine action. On the other hand, it is equally intriguing to encounter believers who oppose the Big Bang theory because they do not understand its origin and believe that it suggests the non-existence of God. If you think about how simplistically Fred Hoyle was able to resume Lemaitre's theory by saying it's just a Big Bang, and then you take the simplicity found in nature, like in the sunflower and the pineapple that we talked about, it is apparent that God's infinity complex designs can often be perceived in simple ways. They are comprehensible to people at whatever level of understanding they are. In the same way, I believe the biblical records of the creation provided an adequate explanation for the Hebrews when it was written. That's it.